Okay, so I'm writing here, and then I will show its demo. Tuning, mapping, and analyzing radio spectrum using software. Along with that, simulation of radio environment. For example, what is meaning of simulation of radio environment? If I want to create my own virtual FM station, generally we listen FM at a particular frequency. Okay. Now I want to simulate a particular FM station. I want to create my own FM station without using actual radio frequency, because there are some legal aspects related to radio frequency. But for my research work, I want to see that this we can implement using GNU radio and so many similar platforms. Okay, using GNU radio, connecting to different bands like medium band, air band, long wave, or ham band, that is also known as amateur radio. I think many of you might be aware with these bands in radio. Ham bands means, so some users, some wireless operators can communicate with each other. Even we can also communicate with each other. For example, I want to talk to somebody without using my mobile phone. Okay, without using my mobile phone, without using my SIM card. Yes. Okay. But as far as walkie-talkie is concerned, or uh, some devices which police or which ambulances use, these are working on some specific frequency. Now, there are two ways. One way is actual communication. We need some devices. You might have heard about some protocols, some applications, some boards like LoRa, long range. If I want to communicate with somebody around 25 kilometers away, with LoRa we can do. Okay, in very less amount, that particular LoRa board can be taken and it can be programmed using MicroPython or C++, or with MicroPython we will be able to program it. Okay, so many things. And along with that, if I want to simulate underwater antenna, okay, so these are some of the features. Okay, however, in software defined radio, so many things available. I want to simulate a particular environment using GNU radio for creating on FM station. Underwater radio network, acoustic network, all of these are possible with this software. GNU radio, free and open source. Free and open source simulator. And not only simulator, it work as emulator also. Emulator or test bed. You might have heard about test bed. Test bed means some part is physical, some part is software based. I want to listen US radio, US broadcasting, that can be done. Okay, because on depending upon time, for example, Vivid Bharati, All India Radio, I want to listen, but not from here, via China. I want to listen All India Radio via Netherlands. It is possible with SDR. Okay, so by which way it is possible? How it is possible? Vivid Bharati is available on AM, okay, on 800 megahertz or 900 megahertz, whatever it is. For example, some FM is 98.1 FM, 100.1 Delhi Gold FM, but it is radiating, it is communicating in only 50-kilometer range or 100-kilometer range. How it is going to another country with with particular short waves, because these are connected to some particular towers. These are also mapped to some short waves also. So with those, it is communicated, it is interfacing with other countries, and via other countries with software defined radio we can capture these signals. Okay, I will show you whatever is possible at this particular time. Okay, so SDR plus plus, this is the software we will discuss in this session. Okay, nowadays these terms, these technologies are very very popular, and lots of research is going on. Even submarines, these communication can also be extracted. Okay, free waterfall. Is it visible to all of you? Kindly confirm. Is it visible? And audio to all participants. Aircraft communicate with AM, not with FM, because in FM what happens, there is noise cancellation, there is the concept of noise cancellation or dominating factor. Are you aware with this particular fact? What is dominating factor in radio frequency? Dominating factor means, for example, two aircrafts are coming. Okay, two aircrafts or two pilots are communicating with each other. If air band use or aircraft communication, they use FM. In that case, what will happen? In that case, for example, one pilot is not getting good signals, and second pilot is getting very good signals, very strong signals. In that case, second pilot signals will superimpose, they will consider first pilot as noise. Even your aircraft handlers, or we call it as air traffic controllers, air traffic controllers will also consider voice of pilot as noise. Okay, for example, one aircraft is in good frequency, in good range, second is not in very good range. In that case, second pilot, where that particular person will go, where that aircraft will go, there may be chance of crash. So where even minute frequency, even minute signals are acceptable or mandatory, in that case we must use AM. For example, in defense, in military applications, we can't use FM, we should not use FM, because in FM there is a concept of superimposition, or there is concept of noise removal. But in military we should not, or in sensitive area we should not go for noise cancellation, because every communication may be important. Okay, for example, A and B, two parties are communicating. B is in danger, B is in danger mode, B is trying to communicate, but B is not getting good signals. Okay, so in that case, what will happen? That will be the sufferer. But if they are using AM, in that case, even less signals will be received, even very less message, or very less intensity of message will be received, but it will be received, it will not be cancelled. Okay, so this is airband, and now I am connecting to AM. Rather, if I will connect to DSB or WFM or NFM, this is this one USB. Okay, upper side band, it will not communicate. Now I am using AM, so you can see that. And in AM, okay, so you can see, so how much decimation? Currently none. Now this is AM, and again I am selecting, this is, you can see, medium wave, and in AM we are communicating. Okay, for example, this one. Yes, real. These are real world signals, actually captured. Actually, you might have seen in machine learning, in data analytics, many data sets are available for research work. Different data sets available. So I'm showing you those platforms. So different data. हाँ जी? If we want to link with real network, in that case we need some devices. We need SDR dongle, hack RF, and then we will be able to link. Otherwise these data sets available. So this is the website IQ engine and so many other websites available. SIG MF. Okay, SIG MF public data sets. If I want for my research work on radio analytics, on software defined radio, I need some aircraft signals. So these are available here. So you can see iqengine.org and SIG MF public data sets. So you can see related to Airbus drones. If you want to take some signals, so 802.11 ah Wi-Fi. Okay, any of these. If you want to take signals related to LTE, if your research work is related to 5G, 6G. Okay, however 6G is not launched, but 5G signals are available. Okay, and those 5G signals or LTE signals you want to analyze, you want to investigate in SDR plus plus or GNU radio. So you can see Bluetooth recordings. Its details are provided in how much frequency, what about the sample rate. Okay, now we will see some. So this is this demo we have seen related to SDR plus plus. Now if I want to capture real signals, in that case we have two options. One is online SDR, online platforms, cloud based SDR dongles, and second is actual dongles comes in a different range, 10,000, if you want to transmit signals as well as receive signals. But for demonstration I want to show, this is the website, and using this I will show how to use SDR for your research work. This is known as online SDR, kiwi SDR. Okay, without using any physical dongle, without using any physical device, without purchasing anything, I want to communicate, I want to interface with different radio stations, with the different short waves, long waves. I want to capture data, so I can use it. How to map dot. So this is the website. I will show you rx.linkfunnel.net. It is part of Kiwi SDR. Now I will connect to some radio frequency. So you can see that this one is on click of this, it is in Netherlands. So I can check whether in Netherlands on 0 to 929 megahertz web SDR, is it capturing all India radio or not? Or is it capturing China radio or any other? Okay, in same way, so this is green means it is currently open, it is capturing data. Okay, other you can see colors, these are restricted. Some from some related to military. Okay, if however it will be connected. Okay, it can be interfaced, but there may be some legal issues. These may be related to some aircraft, some police vans, some ambulances, or these may be related to some private communications between top level authorities. So if I want to communicate with, if I want to see this one, for example, this one Russia. Okay, we will see 2 3. So this is this is software defined radio, without using any particular transmitter receiver in a radio box or in a specific. Now this one, So I will come to Netherlands, and then we will see, because we have to see legal aspects also. So start audio. Okay, now I will communicate on 900 9000 kilohertz. Okay, and this one AM. So you can see that some radio station is cut. We are listening. Obviously, it is not Indian. We are listening some radio station related to Poland. Okay, this one. This is software defined radio, and it is only initial part. Load these signals can be captured. These signals can be captured, can be analyzed, can be decoded. Okay, different so many other settings available. Okay, if I want to work with narrow band or CW continuous waves, that is also possible. So you can explore it.